Hey guys, so in today's video we're going to be going over what a set is, and they're just like lists except for sets are an unordered pair of unique objects. So what I mean by this is if we were to create a variable, we'll go ahead and call it my set. We'll set equals to curly brackets, and we'll go ahead and call the integers 1 through 5. And then if we were to go ahead and print the type of my set, we'd be able to see that my set is a class of set. So the difference between mostly a set and a list is sets will have unique objects. So for example, if we were to go ahead and have another 5 right here, and if we were to go ahead and print my set, what would happen is we would get 1 through 5 again. That's because it only prints out the unique object. So if there are doubles or duplicates, you can go ahead and find out if there are with my set, and it'd just be able to print out essentially non-duplicate items. So in today's video, we're going to go ahead and go over the .add method, the set function. Likewise, we're going to go ahead and index it, and then we're going to go ahead and use the length function, the list function as well with a new variable, just turning them back, and then the .copy and .clear. I'll also have a follow-up video where we'll go over some additional methods, but I figured that we'll just start off with the basics. So if we were to go ahead and use the .add method, we could go ahead and say, for example, .add, and let's go ahead and add like 400. And then let's go ahead and print my set. So the reason I'm doing a print my set is because for those that have been paying attention to my previous videos, I'm wondering, what do you think will happen if we were to go ahead and print this? So if you haven't guessed already, we'd get a none. The reason that we're getting none is because what's happening is we're adding 400 to the set itself, and it's not really providing like a value. It's mostly performing an action on the set, and then that's why we're able to print it out below when we print my set again. But because we're having the action take place, no value is essentially being returned. So that's why we're having none printed out rather than 400 as part of the set twice. So when it comes to sets, you can also go ahead and say, for example, let's say we were to go ahead and change the set to a list. We could call the list function. And what that would do for us is it would obviously change the set into a list, and then you could go ahead and manipulate the list from there however you'd like. But what you could also do is if, for example, you are dealing with a list and you want to see it as a set, you can go ahead and use the set method. But before I do that, this actually just caught my eye. Notice that up here, I still have 2 5s, and I'm printing out my set. And you would assume because it's a list, it would go ahead and print out both 5s. So if we were to go ahead and change this back to a list, actually let's copy and paste it. So if we were to go ahead and just print this out as a list, you would assume that obviously the 2 5s would be printed out because it's a list. And then let's change it to my list. So if we print it out right here, and let's go ahead and add a separator. Times 40. Now I'm just printing out the times 40 to go ahead and add just some room for us to go ahead and see the difference. So notice, back to why I brought this up initially, is the 2 sets right here, even though they have 2 5s, they're still not being printed out, even though we're changing it to a list function. That's because this is still technically considered a set, and as it's considered a set, it will only produce the unique objects. So always remember, start inward and then go outward. So we're starting with the set. That initially nulls the additional value right here. It gets rid of it pretty much. And then it turns it into a list, and then we're going to go ahead and print out that list. Whereas down here, it's already established as a list, and then it'll go ahead and print out the list, and that's why we're getting the 2 5s. This one starts as a set, this one starts as a list. So that's why we're getting the different values within the set. But as another option, if you see, well, I'll just bring this up now. Because you see the two fives, if you wanted to say, for example, get rid of the two fives as a list, what you could do is you call the set function. And if we were to go ahead and print that out, what we would get is now a set, and it would get rid of the second five. So again, sets will only provide unique objects within the values, I mean. So that'll kind of lead us on to the next thing that I want to get into, which is indexing versus the in keyword for the set itself. I'm going to go ahead and comment these out for now. And then let's leave view. So if we were to go ahead and get rid of this, we'll leave the add. And then let's say we want to index position 0, for example. Let's say we potentially want to do that. Now, had I turned off my notifications within my computer, you'd notice that obviously I'm getting an error, but ultimately set objects is not subscriptable. So as you see, you're not able to use the index itself. What I mean by this is you can't really index within a set, but what you can do is you could use the in keyword. So for example, if we were to get rid of 0 or my set, we could say 0 in my set, and we can see if 0 is in the set itself, but that's false. If, for example, we would say 400, we'd be able to see that that's true. So you won't be able to use index like you would for list to be able to index the items within the list, but you can use the in keyword. And again, the in keyword is just a keyword built into Python. There are many others, and I'll go ahead and link in the description, and I'll set myself a reminder to link in the description. I spelled that wrong. That there are additional keywords. I spelled that wrong. That's okay. So we'll kind of move on to the next one though. So for this, we could go ahead and use the length function to go ahead and see how many items are within a list itself. And before we do that, let's go ahead and print out some additional adds to just prove a point. So we'll go with 450, 20, 10, and we'll go with 8. And if we were to go ahead and say print the length of my set, you could see how many items are within the set itself. And in our case, there are 9. That's obviously because we added these items here, but if we were to go ahead and get rid of the 4 items, we should return 5. And you'll see that there are 1, 2, 3, 4, and 5. But again, a set is a unique object. So that's why the second 5 isn't showing up. So just remember, when working with sets, even the length will only determine the unique objects within the set itself, and that could become very useful down the road if you're in data science, or obviously in anything else that you are using a set for in function, or a set for in Python. Sets are actually very useful though when working with primary keys. So if you are setting up like a database and you want to be able to see a person's SSN, an email, or a username, you can use a set to go ahead and carry all the items, and then you can use that as their primary key. And what I mean by primary key is a unique identifier that only one person can have. I used to work at a financial firm where we used the username rather than an email as a primary key, and many people would misspell their emails, and then we wouldn't be able to adjust their email because their username had the proper email, and that was the primary key, and we can adjust that, but people wanted to use their email, and that just caused a whole big headache for us, just trying to figure out how to allow people to create new accounts with us when they had screwed up on their email address, but their username was spelled properly. So I don't know, there's just a lot of different ways to use it. So when you do set a primary key, just be certain that you actually want the email to be used as a primary key or whatever item you want to use. Next, we'll go ahead and get into the .copy and the .clear methods. So when working with sets, let's go ahead and uncomment this out. And for those that don't know, to uncomment, I'm using Control /. For a Mac, I believe it's Command /. I'm not certain. But when it comes to the .copy method, let's go ahead and uncomment these as well. And then let's go ahead and we'll do a my set2 equals my set.copy. And all that's happening right here is if we were to go ahead and print out my set2, is we're printing out a copy of the initial set. So again, we're having none for these, but for this one, for when we print out the second set, we're able to see the additional items within the set itself. That's because obviously we're printing out a copy of it. So if you want to say, for example, manipulate this set, we could do let's go ahead and do my set2.add, and then we'll say, I don't know, 500 for this one. And if we were to go ahead and print that out, we'd all still get the same items, but we'd be able to see that 500 was added to the second set because it's a copy of it. And if we were to go ahead and print out my set, we'd see that 500 isn't added to the first set because the second set is just a copy of the first set. So let's go ahead and change this up just so I don't stop saying my set2. We'll call this set2. And then likewise, this one will be set2. But ultimately, just copy. If ever you just need to copy something, just go ahead and use the .copy method. Same thing for lists. If ever you need to copy another list, just use .copy. And then that'll kind of bring us to our last item for the day, which is the .clear function or method. So if we're to go ahead and do a my set, and we're just say .clear. If you haven't already guessed it, what would happen is, and then let's go ahead and add a separator so it's easier to see. If we were to go ahead and print that out, we would get a cleared set. So essentially, we're not really getting any items within the set itself, but we are having a set function called. But essentially, it's being cleared out right here. So after that, if you want to go ahead and manipulate it further, what you could do is you could go ahead and say my set .add, and then you could kind of start over again. So we could do like 500. And then we could go ahead and print out my set again. And then if we were to go ahead and print that out, we would then have one set, the initial set that was cleared, and then one set with just 500 in it. So then you could start over. Just know if you do clear it, it will be permanent for the rest of the time you're working within whatever algorithm you happen to be creating. So just know it's permanent, but you could always possibly just assign it like a new variable. So we could just do this new variable equals my set.clear, and then you could go ahead and print out the variable itself, the new variable, and that'll just be pretty much a newer variable that's empty. So if we're to go ahead and print out my new variable, we would then see obviously that we're getting the set itself. So hopefully this makes a little bit of sense. I'll go ahead and add some additional questions in the bottom here, wherever that is, in the bottom. So I'll add some more questions right here, and I'll set a reminder for myself. I'll go ahead and link it to my GitHub so you guys can get some practice with sets. And in the next video, we're going to go ahead and go over the remainder of these functions, where we'll go ahead and learn how each of these functions can be interacted with a set. I figured that this would be just enough to kind of go over for this video. So I want to thank you guys for checking this video out. Please check out the description for the additional links and get some practice on the GitHub. So thanks for checking this video out, and I'll see you in the next one. Thanks, guys.